Hello everyone. Let us continue with the theory of probability. So today we will discuss sample space, events, and axioms. Now what is sample space? It is a set of all possible outcomes of a random experiment denoted by S. So when we conduct a random experiment, then what are the possible outcomes? So total number of possible outcomes, that is the sample space. Suppose a dice is rolled. We know that a dice has 6 faces, 1, 2, 3, 4, 5, 6. So if we roll, then sample space will be 1, 2, 3, 4, 5 and 6, because one may come when the dice will stop. Say in the upper surface, 1 may come, 2 may come, 3 may come, 4 may come, 5 may come, or 6 may come. So total possible outcomes are 6. So it is denoted by S. So S is equal to, so we should remember the set theory. Now events, these are a subset of sample space. So events are within the sample space. It is a group of one or more outcomes of interest. It may be one or a more than one, or a group of outcomes of interest. Or we say, favorable case. Suppose 2 dice are rolled simultaneously. So we have taken in hands 2 dice and we have rolled simultaneously. Getting the numbers whose sum is 12 is 6, 6. So if our favorable case is 12, that means the number, if we plus the number coming out from first dice and second dice, the sum must be 12. Now this favorable case will be 6 and 6 only, because maximum number is 6. So 6 plus 6 will be 12. No other number. So event will be 1. And probability is 1 by 36. Is this denoted as X? X is the event such that it is included. So X, this outcome, or it is such that it is included in sample space and it ranges, value ranges between 0 and 1. That means the probability is from 0 within 1, from 0 to 1. Now what is independent events? Occurrence of one event will not affect the probability of the occurrence of the second event. So it is independent in the sense that if one event occurs, it will not affect the probability of occurrence of the second event. So in that case it is independent. So probability of AB is equal to probability of A into probability of B. Probability of A, of event A, and probability of B is the probability of event B. PAB, probability of AB, then probability of events A and B occurring both, also called joint probability. So probability of AB means probability of events A and B occurring both. This is also called joint probability. And P dash A is the symbol of conditional probability. It is probability of event B given that A has already occurred. So this is generally used in the conditional probability. The symbol is this. Meaning is that A has already occurred. A has already occurred, and it is the probability of event B given that A has already occurred. If two events are independent, P and B, so this is equal to probability of B. So PAB is equal to probability of A. If two events are independent, occurrence of one does not affect the probability of occurrence of the other. So if it is this, we can directly say that probability of it is the probability of A because B has already occurred. Then dependent events. Occurrence of the events affects the probability of the occurrence of the second event. So it is just reverse of this, that if one event has already occurred, then this will affect the occurrence of the second event. Events are mutually exclusive. So in this case, it is called mutually exclusive cases. Mutually exclusive. If A has occurred, probability of occurring B is 0. This is called dependent events. Now axioms. Now what are axioms? The meaning of axioms is, it is proof, self-proof. There is no need of experiment. Axioms. There are 3 axioms of probability. So let R is equal to sample space made up of sample events. So suppose R is the sample space we have discussed, sample space, and F field generated from R, and EI sample points or sample events. Okay, let us continue. Then the axioms are, number 1, a non-negative real number is associated to each event as probability of event EI, denoted by probability EI, is greater than or equal to 0. That means it is positive. So probability is always assigned with a positive number. It should be a real number but non-negative. So probability is never negative. So a non-negative real number is associated to each event as probability of event EI, denoted by probability EI, is positive, greater than or equal to 0. Okay. Second, probability of the space is equal to 1. So total it is just to understand, it is total probability. Total probability is always 1. So it is never greater than 1. So probability is always, total probability is always 1. Number 3, if A and B are 2 events, suppose A and B are 2 events in the field F, and A and B have no elements in common. So these are the 2 events and A and B, they do not have common elements. In that case, probability of A union B is written as probability of A plus probability of B if there is no common elements. So AUB can be written as A plus B. So we have got it in the set theory that A union B and since R is equal to E1 union E2 union E3 and so on union En, then we can write probability of event 1 plus probability of event 2 so on plus probability of event n is equal to 1. That means probability of all events, sum of probabilities of all events is equal to 1. It cannot exceed 1. Now there is one illustration. Suppose a dice is tossed. We know that a dice has 6 faces. So when a dice is tossed, now sample points will be 6. So E1, E2, E3, E4 and E6, there will be 6. So E1, E2 up to 6. The non-negative number assigned to each, that means the probability is 1 by 6. So probability of happening E1 is 1 by 6. So it is written as P probability of EI8. I8E, that means I ranges from 1 to 6. So I may be 1, 2, 3, so on. So probability of EI is equal to 1 by 6. Then total probability is equal to P E1 plus P probability E2 so on over probability E6 is equal to 1 by 6 plus 1 by 6 so on 1 by 6 is equal to 1. So we have written that we have seen that total probability of R is equal to 1. So total probability will be 1. So let A is an event that 1 or 2 or both occurs. Suppose A is an event that 1 or 2 occurs. When the dice is tossed, 1 may occur or 2 may occur in event 1 or both will occur. Then it is written as A is equal to E1 union E2. A or 2 will occur. A E1 union E2. And E1, E2, that means both occurs, that is 0. So in one dice, in one single toss. So even E1 and E2 cannot occur. Okay, both cannot occur. As 1 and 2 cannot occur simultaneously. So it is written expressed like this: E1, E2 is equal to occur. This means it cannot occur simultaneously. So A is equal to E1 plus E2. A is equal to E1 union E2 means E1 plus E2. Either 1 or 2 will occur. Either 1 will occur or 2 will occur. Then PA is equal to PE1 plus PE2 is equal to 2 by 6. So we have seen that E1 is 1 by 6, E2 probability of E2 is 1 by 6. So if we sum of 1 by 6 plus 1 by 6, it is 2 by 6. So similarly, in B, either E3 or E4 occurs, then probability of B is equal to probability E3 plus probability E4 is equal to 2 by 6. Then probability of either A or B occurs. See, probability of either A or B occurs. It is denoted as like this: probability A union B. That means probability of A plus probability of B is equal to 2 by 6 plus 2 by 6 is equal to 4 by 6. So this indicates that when a dice is tossed, now what is the meaning of this? When a dice is tossed, the probability of occurring 1, 2, 3 or 4, 1, 2, 3 or 4 is 4 by 6 because here both A and B are involved. So for A 1 and 2, for B 3 or 4, so probability is 2 by 6 plus 2 by 6 is equal to 4 by 6. So this is all about axioms. And so next is deduction of theorems based on axioms. The theorem 1. So probability of phi is equal to 0. So event A1 union A2 union A3 so on is equal to total sample space. And event AI and intersection of event AJ when I is not equal to J is phi. This means if event is 1, A1, so next event should not be A1. It is other than A1. That's why it is I not equal to J. There should be odd, but not even. So their intersection is phi, and probability of such intersection is 0. So sample space union phi is equal to S, again sample space, and sample space intersection of phi is equal to phi. Then probability of S union phi is equal to probability of sample space. So is equal to probability of sample space plus probability of phi. So since probability of phi is 0, we have got earlier, so PS plus P phi is equal to PS because it is 0. So we can say that probability of sample space union phi is equal to probability of sample space. Then theorem 2, probability of A bar is equal to 1 minus probability of A. A bar is nothing but event not happening. So probability of event not happening is equal to total probability 1 minus probability of happening. That is the. Now how to prove this? That A union A bar, that means events of happening union events of not happening is equal to S. Total is S. That means total sample space. Then event of happening, then intersection of event of not happening is equal to phi. So probability of event happening and union event not happening is equal to PS, probability of sample space. Sample space is equal to 1 is equal to PA plus PA bar from this relationship. From this relationship, 1 is equal if P A bar probability of not happening is equal to 1 minus probability of happening events. So we can write 1 is equal to this plus this. If we transfer towards left side, 1 is equal to probability of not happening plus probability of happening. So 1 is equal to this. As probability of not happening is equal to 1 minus probability of happening. So it is proof that probability of not happening is equal to probability of total probability minus probability of happening events. Then theorem 3. A is included in B. This is an inclusion sign. Or we say A is an element in B, or A is a subset in B, is equal to probability A less than or equal to probability of B. So how that A inclusion B leads to A union B intersection A probability event not happening is equal to B union A is equal to B. And also A intersection B intersection A bar, that means not happening, is equal to pi. So that probability of A union B intersection A bar not happening is equal to probability of A as per rule of probability. Probability of A plus, there are two terms, A and this. A is A union this. This means probability of A plus probability of B intersection A bar. Now this is equal to probability of B, and this is positive. This is positive, but probability of B intersection A bar is greater than or equal to 0. That means it is a positive number. So PA, this is positive, some numbers, it is a positive number. So PA must be less than or equal to, that means probability of A must be less than or equal to probability of B. So this plus this is equal to this. Necessarily, this must be smaller than this because it is a positive number. Now theorem 4. Probability of an event ranges between 0 and 1 for any event A in sample space, total sample space. So event A is included in total sample space, implies probability of A less than or equal to probability of S, because it is included in S. So it may be subset or it is an element included in S, or total event, it is an event included in total sample space. So necessarily A is smaller, then the probability of A will be smaller than the probability of sample space. This implies probability of A, that means event, is less than or equal to 1, because total probability P of S, total probability of total sample space is always 1. So we can write probability of event A less than or equal to 1. From axiom, probability A greater than or equal to 0, it follows that P, probability of P will range from 0 to 1. Okay. Now this is a simple theorem of total probability. So this diagram, so A, event A and event B, and it has intersections. So probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. So we must take the probability of A, total A, then total B, then we must subtract this intersection. Probability of this intersection we will have to subtract. So probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. So I think this is a simple, and with this we have concluded the axioms and the theorems. Thank you for watching. Go on watching and please share.